Hey there guys, welcome to your part 1 video for chapter 1.5, the trig of right angle triangles and indirect measurements. Now the two main topics we're going to be covering is first the Pythagorean theorem, which states that a squared plus b squared equals c squared, where a and b are the legs of the triangle and c refers to the hypotenuse of the triangle. Now remember, you can always find the hypotenuse of a triangle because it's directly in front of the right angle. And then the legs are the non-hypotenuse sides of your triangle. So here's an example. So if you're asked to calculate the length of AB, so side AB, in the right angled triangle, which just means a right angle triangle, this symbol just means triangle ABC. So if we want to find the side of AB from the triangle ABC, where CB, this side, our hypotenuse, is 15 centimeters, and AC, right here, a given sign, is 7 centimeters. So we're given the hypotenuse. Once again, we know it's the hypotenuse because it's the longest side, as well as because it's directly in front of my right angle. I'm also given one of the sides. I have to find the third side of my triangle. Since this is a right angle triangle and I'm given two of the sides, I can use the Pythagorean theorem. So I'll use a squared plus b squared equals c squared, where this is a squared, this is b squared. Hypotenuse is always c squared. So I'll plug it in. I don't know AB. Side AB, that's what I'm trying to find. So I'm going to leave it as a variable, AB squared, plus, I do know this side, so 7 squared equals 15 squared. Now, really important, in this case, since I don't know this, I need to solve for AB. So what I'm going to do is I'm going to subtract 7 squared from both sides, which is why there is a minus 7. And remember, the inverse of squaring anything is square rooting. So to get rid of this squared, and to get AB by itself, I'm going to square root. So all you ended up doing was subtracting the 7 squared and then square rooting the difference, which will give you 13.3. But we'll do another few examples. So in these cases, we're given some of the sides and we're asked to find the missing one. So in this case, we're given, okay, my side 13, my side 12.12. I do not know the hypotenuse AC. Now I know this is the hypotenuse because once again, it's the longest side. It's also directly in front of my right angle. So the first thing I'm going to do is set up my formula where a squared plus b squared equals c squared. In this case, since I'm solving for the hypotenuse, I don't have to rearrange it. I will just solve what I know. So 13 squared is 169. 12.2 squared is 148.84 equals w squared. Now, like we said before, after you find your sum and you want to get w by itself, since it's being squared, the opposite of squaring a number is square rooting a number. So if I take the square root of w squared, that cancels out the square. But what you do to one side, you have to do to the other. So I'll take the square root of here. The square root of 317.84 is 17.82.80 ... because it's actually a very long number. But it's asking us to round to one decimal place, which will give me w equals 17.8. We'll do a similar thing here. So in this case, we're still trying to find the missing length. In this case, it is length b. So I'll set up my formula, a squared plus b squared c squared. In this case, I know this leg, my a squared, but I don't know my b squared. I do know my hypotenuse, so it's going to go at the equal sign where c usually goes. So this is similar to the first example we did where we don't know one of the legs. We know the hypotenuse and we know the first leg, but we don't know the second leg. So what you do is first you can figure out what these numbers are. So 6.1 squared is just 37.21. 9.7 squared is just 94.09. Now we want to get b by itself. So since we're adding 37.21, we're just going to subtract that from both sides. So we're just subtracting it. That'll cancel out. 94.09 minus this number is 56.88. But it doesn't say b equals, it says b squared equals. So we'll take the square root of both sides. That'll cancel out the squared, which leaves me with b by itself. And the square root of 56.88 is a 7.541888, and so on and so forth. But we only want to round to one decimal place. So my side length b is 7.5. Something else that we're going to cover in this video is trigonometric ratios. This might be something new that you might not have seen before. Depends on what kind of math classes you've taken before. So trig ratios, what is usually called, is SOHCAHTOA. So you probably have seen this in geometry, where SO stands for sine, opposite over hypotenuse. So you'll usually see written it like this. Ka is cosine, is adjacent over hypotenuse. And TOA stands for tangent, is opposite over adjacent. Now, opposite, hypotenuse, adjacent, all relative to the angle we're discussing. So in this case, if we're discussing angle A, this is my main reference point. So from angle A, that's a bad arrow, but from angle A, we can see that this is my opposite side. Adjacent just kind of means on the same side or touching that angle. So we have adjacent. Hypotenuse will always be the longest side. Hypotenuse will always be the side in front of the right angle. So it's just really a ratio and the relationship between sides and angles of triangles. And once again, opposite and adjacent refer to the sides that are opposite and adjacent to angle A. For angle C in this case, opposite would be here, adjacent would be here. So it all refers to what angle you're referring to. But the hypotenuse will always be the angle in front of the right angle. But let's do some examples. So we're going to write SOHCAHTOA. Usually it's written like this to remind us. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. Now we're asked to find the length of the unknown sides of this right angle triangle. We can't use the Pythagorean theorem because we only know one side. I don't know x and I don't know z. But I can use trig ratios. You can use trig ratios when you know one of the angles and one of the sides of a right angle triangle. So this is my reference point. So there's different things we can do. We solve it separately. So first we'll solve for x. So if we do this from 34, the 10.2 is opposite. So I know I'm going to use a trig ratio that's using opposite. So either I'm going to use sine or tangent. And then if I want to solve for x, x is the side that's touching this angle. This is my adjacent. So opposite over adjacent is t, which means I'm going to be using tangent. Oh, got a little bit ahead. So tangent of the angle given, so tangent 34 equals my ratio opposite, which is 10.2, over my adjacent x, which I don't know. From here, it's just a math problem. I know to get rid of this x, it's being divided by x. The opposite of dividing by x is multiplying by x. I'm going to multiply by x on both sides. So I'll get tangent 34 times x equals 10.2. I want to get x by itself, so I'm going to divide both sides by tangent 34. So you'll end up with x equals 10.2 divided by tangent 34. You'll put this into your calculator, and once you put it into your calculator, you'll get x equals 15.1221, which is one of them that we solved for, but there's another unknown side. Now, what you can do, now that you know two of the three sides, you can use the Pythagorean theorem to find the third side. So you can do a squared plus b squared equals c squared, or you can use trig ratios again. So let me see if I can erase. There we go. So this time I'm still going to use this as my reference angle, but I want to solve for z this time. So 10.2 is still my opposite, except this time the z is not adjacent. Although it is touching this angle, it's actually the hypotenuse because it's opposite from the right angle. So hypotenuse is always the side that's the longest side, as well as the side that's opposite from your right angle. So this is opposite and hypotenuse. If I look at my trig ratios, opposite and hypotenuse means I'm using sine. So we're going to use this degree still. So sine 34 and my ratio, opposite, which is 10.2 over hypotenuse, which is z. We'll do the exact same thing we did here. We're dividing by z, so I'm going to multiply by z on both sides, which will give me sine 34z equals 10.2. I want to get z by itself, so I'm going to divide both sides by sine 34, which will leave me with z equals 10.2 over sine 34. Once you put this into your calculator, you will get the answer. Z equals 18.2406. Now you can always check your answers to kind of see if they make sense. So for example, your hypotenuse, which is z, should be the longest side. 10.2 and 15 are both smaller than hypotenuse of 18. So we can kind of logically assume that we did this correctly. Let's do one more example. So don't forget your trig ratios. You should have it written down somewhere when you're doing these type of problems, or just memorize SOHCAHTOA. So we want to find x and y. Once again, we cannot use the Pythagorean theorem because we're only given one side. So here's the reference angle they gave me, the 66.4. From the 66.4, I have opposite. So I'm going to use sine or tangent. It depends on whether I want to solve for x or y. So let's say I want to start with x. Well, x is adjacent because it's touching my angle and it is not the hypotenuse. The hypotenuse is y, which is my longest side. So if I'm going to be doing opposite and adjacent, I'm doing tangent again. So I'm going to do tangent of my angle 66.4 and my ratio opposite over adjacent 21.3 over my x. Similar to before, you're going to multiply both sides by x to get tangent 66.4x equals 21.3. To get x by itself, I'm going to divide both sides by this tangent 66.4, which will give you this new division sign or division problem. Once you put that into your calculator, you will get 9.30574. So you'll get this. That is your answer. But we're not done because we have to find y. Once again, technically, now that you have two sides, you can use the Pythagorean theorem to find your third side, but just for more practice, we'll keep using trig ratios. So I'm still using 66.4. I still have an opposite, which is 21.3, but this time I want to solve for y. This time, y is hypotenuse because once again, it is my longest side. It is the side that is opposite to the right angle. So opposite over hypotenuse is sine. So I'm going to write my sine trig ratio, opposite, which is 21.3, over my hypotenuse, which is y. Multiply both sides by y. Divide both sides by sine 66.4. Put it into my calculator and you will get y equals 23.2441. Now I solve for both sides, x and y. Logically, it makes sense because y is my longest side. It is larger than x. It is also longer than 21.3. And the legs are relatively close to each other. So we know that we did it correctly. So that's all we're going to do in our video. Don't forget to do your Delta Math, and we'll do more practice in class. If you have any questions, feel free to send me a message on Remind, email me, or sign up for tutoring. Have a nice day.